Have you ever wished you could teleport? Just imagine, one moment you're in your living room, the next you're on a beach in Hawaii. The idea of teleportation has captivated our imaginations for years. It's been a staple of science fiction, from the transporter rooms of Star Trek to the apparition spells of Harry Potter. The allure of instantly traversing vast distances is irresistible, isn't it? Yet teleportation isn't just a whimsical notion found in films and novels. It's a subject that has piqued the interest of scientists across the globe. They've been exploring the theoretical underpinnings and potential of this concept, pushing the boundaries of what we understand about our universe. Indeed, the concept of teleportation is as fascinating as it is complex. It invites us to dream, to question, and to explore the realm of possibilities. But before you start packing your beach gear, let's dive into the science behind teleportation. Teleportation might not be as far-fetched as we once thought, thanks to a little thing called quantum mechanics. Now, quantum mechanics, believe it or not, is the branch of physics that deals with the smallest particles in the universe. We're talking about atoms, photons, and even subatomic particles like electrons and quarks. It's a world where the rules of classical physics that you and I are familiar with just don't apply. Now, let's bring in another term. Quantum entanglement. Sounds fancy, right? But don't worry, we'll make it simple. Imagine you have a pair of dice. No matter how far apart you take them, when you roll one, the other instantly shows the same number. That's quantum entanglement in a nutshell. Two particles become entangled in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. So, how does this relate to teleportation? Well, it all comes down to a process called quantum teleportation. This isn't your typical sci-fi teleportation where an object disappears from one place and reappears in another. Instead, it's about transferring the state of one particle to another. It's like if you had two cars, one red and one blue, and you could make the blue one turn red just by looking at the red one. That's quantum teleportation. And here's the kicker. Scientists have already done this. They've successfully teleported the state of one particle to another over long distances. In 2017, Chinese scientists were able to teleport a photon from Earth to an orbiting satellite over 870 miles away, setting a new record for quantum teleportation distance. But hold on, you might be thinking, a photon is not a person. And you're absolutely right. Teleporting an entire human being, with our trillions and trillions of atoms, is a whole other ballgame and presents a host of challenges. So we've managed to teleport particles, but what about larger objects like humans? Well, that's a question for another day and another scene. Stay tuned. While teleporting a human is currently beyond our reach, it's not for lack of trying. The idea of teleporting larger objects or even humans presents a myriad of challenges that scientists are still grappling with. Firstly, there's the need for incredibly precise measurements. Imagine trying to pinpoint every single atom in the human body and then perfectly reassembling them in another location. Sounds impossible, doesn't it? Not to mention the fact that humans are not static. We're constantly changing. With atoms coming and going, cells dividing, and our bodies moving even if just slightly. Capturing a precise snapshot of this constant flux is a daunting task. Then, there's the data. The amount of information needed to describe a human at the atomic level is mind-boggling. It's been estimated that encoding just the human brain would require 1 followed by 42 zeros bytes of data. That's more data than is contained in all the libraries in the world, and that's just the brain. The entire human body would require exponentially more. Storing, transmitting, and processing this data is currently far beyond our technological capabilities. Lastly, there are the potential risks. Even if we could overcome the first two challenges, what about the potential dangers? What happens if the teleportation process isn't perfect? Could a slight mistake in reassembly lead to catastrophic consequences? These are questions that we don't yet have answers for. Despite these challenges, the field of quantum mechanics continues to push the boundaries of what we thought was possible. Quantum teleportation, the process of transferring quantum information from one place to another, has already been achieved with tiny particles. Could this be a stepping stone towards teleporting larger objects, or even humans? So, while you might not be teleporting to your dream destination anytime soon, who knows what the future of science might bring? The reality of teleportation may still be a distant dream, but the journey towards it is fascinating. The quest for teleportation, like any scientific pursuit, is a testament to human curiosity and innovation. Even as we grapple with the complexities of quantum mechanics and the enormity of the technical challenges, we continue to push the boundaries of what's possible. So, Keep dreaming about teleportation. After all, today's science fiction often becomes tomorrow's science fact.